All right, so for number 4, it's fairly easy, but you do have to understand one or two key concepts. Okay, in this exercise, they definitely try to catch you by saying things like the other way around or the mirror version, and you have to know like what's the consistent approach. And once you have that, this exercise is actually really easy. So they tell us that the total number of children, which is going to be our y, are visiting a park, which depends. And this is a huge word because it talks about the relationship between these two variables. Visiting a park depends on the highest temperature T in degrees Celsius. And so the amount of children that go to this park depends on the temperature, which makes sense because if it's really cold, if it's snowing, who's going to go to the park? If it's really, really, really hot, who's going to go to the park, right? So that kind of idea is what they're telling us here. And that the park official predicts that the total number of children visiting his park on any given day, uh, you can predict it by using this model there. And so clearly, the park official took Math IB at some point because, I mean, that park official knows what's up. See? And so the park official says that you can predict the number of children using this formula where this occurs. Okay, and this, ladies and gentlemen, is what we're going to call our domain. Okay, and so our domain, just to exemplify real quick, our domain is going to be the possible values for x. Values for x. See? But here, there is no x, right? There is t. And so this is very interesting. Basically, this equation here is the same as this equation here. All right? Instead of t's, you would have x, right? And this is the main idea that we need to capture from this exercise. Really, the domain, when we talk about possible values for x, it's not really x, it's the possible values of your independent variable. And this is something I really need to introduce, and we all need to be on the same page. When you have y equals something, then that means that this y is your dependent variable. And I'm sure you've seen this in 1 or 2 science classes, but the main idea is that your dependent variable is only one, and it depends, of course, it depends on a bunch of other variables and a bunch of different x's and this and that. Okay, and so your dependent variable depends on a bunch of different x's. So you have one dependent variable, you have one y equals with a bunch of independent variables, a bunch of x's. See? And so the domain is for the values of x, which is the values of your independent variable, while the dependent variable is the range, which is the possible values. Possible values. I missed the E here. Range, possible values for y. And so this is the main difference and the main thing we really need to capture from this. Independent variable will be your x, while dependent variable will be your y. This is very important for us to understand right away because down the line it's going to be essential. Okay? So anyways, use this model to estimate the number of children in the park on a day where the highest temperature is 25 degrees. And so for part A, it's pretty straightforward. They are giving us the massive hint that we need to estimate the number of children, right? And so if we estimate the number of children, we're asking for what is y. And when they tell us that the highest temperature is 25 degrees, then they're also telling us that T equals 25. So basically, when T equals 25, what is y? That is what part A is asking us to do. So if I write down my equation real quick, we have y equals negative 0.6 t squared plus 23t plus 110. So as I said, what is y when t equals 25? You plug in t equals 25. Technically, you can also do it as like you're plugging in 25, right? So y of 25, negative 0.6 times 25 squared plus 23 times 25 plus 110. Now, unless you're very good at mental math, you're going to go ahead and pull out your graphing calculator here because remember, this is paper 2. You can use your graphing calculator. So negative 0.6 times 25 squared plus 23 times 25 plus 110. And so for part A, we got 310. And so this means that when t equals 25, y has to equal 310. Okay, and this, which I'm putting in blue, is basically like my final answer. If you want to get full credits, well, you did your method down here by showing that you plugged in 25. That's a very important step. And I guess the last thing you can say is that it's 310 children on the park. And so for part A, it's pretty straightforward. It's just interpreting your values, etc., etc. Down the line, they tell us that an ice cream vendor wants to investigate the relationship between the total number of children visiting the park and the number of ice creams sold X. The following table shows the data collected on 5 different days. And so here we go back to the idea of dependent and independent variable. And so in this context, what this ice cream vendor is doing, okay, this is very important. What the ice cream vendor is doing is that he wants to see how does your Y change when your X changes. Okay? He wants to see the relationship between the total number of children and the numbers of ice cream sold. And so basically it's how does the number of children change when the amount of ice cream sold changes. Okay, so his priority is understanding how his Y changes. And so his dependent variable is Y, and his explicative variable, the independent variable, is X. Okay, that is for the ice cream vendor. Okay, and so basically the ice cream vendor is telling you, okay, so when there is 15 ice cream sold, there's around 81 children. When there's 27 ice creams sold, there's around 175 children. When there are 46 ice creams sold, there are 360 children. And so this ice cream vendor is very interested in how I just like detailed it, right? So he's saying that your ice cream is X, and so he wants to see changing the amount of ice cream you eat, how does that affect the total number of children? Okay, this is just for the ice cream vendor, all right? But part B, and this is where you need to be very careful. You need to read very carefully because here it says, find an appropriate regression equation. Okay, so this is already a massive like buzzword. See, the moment they talk about regression equation, you should be thinking of line reg on the calculator. Okay, so this is a massive buzzword you can write down somewhere. Regression equation, you gotta think of line reg. Okay, and so find an appropriate regression equation that will allow the vendor to predict, and careful, what is he to predict? Predict the number of ice creams sold. And so predict the number of ice creams sold on a day when there are Y children in the park. And so suddenly, notice how this is a little bit flipped. See, and it's very important that you notice this because that is, where they try to catch you. See? So I usually say that the IB doesn't try to catch you, and I mean it in the sense that the diagram tends to have everything, they give you all the information you need, and here they sort of catch you because they give you the table saying that ice cream is X and that total number of children is Y. And so the moment they put Y on top and X on the bottom, they're basically saying that your dependent is up top while your independent is on the bottom. And so this is the perspective of the ice cream vendor. But for part B, it's very interesting because for part B, it tells you that you need to make a regression equation that will allow the vendor to predict what? Predict the number of ice creams sold. And so suddenly what you're predicting is the number of ice creams, so your dependent is number of ice creams. Will you look at that? On a day where there are Y children in the park, so this is what explains, right? And so this is now your independent, right? And so suddenly, now that we understand that, I'm following what I'm putting in green, your total number of children is suddenly now going to be your X, and your ice cream sold is going to be your Y, right? And so this is a massive sort of concept we need to really acknowledge in our heads. Initially, the ice cream vendor, they tell us that total number is Y. Total number of children is Y, that the ice cream sold is X, that he's using the ice creams to explain the number of children. But for part B, it's a little bit different. They want you to explain the number of ice creams sold. They want you to predict the number of ice creams sold, based on the children. So basically part B is the other way around. It's taking this number, what should this be? Taking this number, what should this be? It's the other way around, quite literally. And so for part B, well, you gotta do line reg on your calculator and using the independent as number of children. So your x is now number of children, right? And your y, or actually, I'm just gonna cross it out here so we're on the same page, right? And so for part B, now you're facing that this is x and that this is y. See? All because they said that they want to predict the number of ice creams, and so whatever you're predicting is going to be your y. Same as up here, whatever you're predicting is your y. Okay? So that is the main idea. That is why this monologue was so long. Whatever you're predicting is your y. Whatever you're predicting is your dependent variable. Whatever you're predicting is alone. Okay? It's y equals blah, blah, blah. See? All right, cool. So now that we got that like really into our heads, let's go ahead and open up the calculator. See? And so from here, as we noticed, they said regression equation. See? And so a regression equation, let me talk about that real quick. Then I will show what the calculator does. A regression equation is basically like you have a scatter plot, see, which is a bunch of different points. Okay? And that regression equation is something that's gonna try to cut through as many of these as possible, right? Now it's a straight line, and so of course you can't go like boom, 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 boom. That's not fair. But what you will do is sort of like take the average of everything and say, this roughly cuts through the middle. See? And so conceptually it makes a lot of sense. This green line is like as close as possible to all the points. And this would be your regression equation, right? Why is a regression equation useful? It's useful because it can help you learn like the correlation of your data or like how X behaves on Y. It can help you understand if it's a positive correlation, if it's a negative correlation. In this example that I made up, as X increases, so does Y. All right, so maybe this is like, dude, I don't know, like marathons ran and like weight lost or something, you know? And so that's the main idea. A regression equation is very useful for understanding how your variables behave with each other, specifically the direction that they take. All right, the correlation, this or that, blah blah blah. And so in this problem, they said regression equation. So we're thinking line reg in our calculator immediately. So you go ahead, open up your calculator. Enough talking. Let's jump into it. Your line reg is going to be in stat. See? Now what I like to show is that your calculator has a lot to it. See? So I don't expect you to memorize everything, but I do expect you to know like what's in it. See? And so I do expect you to read and say regression equation. Ah, that's line reg. See? I know it's somewhere in here. So eventually, after digging a lot, you're gonna find that it's in stat, and then calc, and the fourth one, line reg. So what I want you to do the day of the test is that you identify you need to use line reg, you go to line reg, you press line reg. And now and only now do you realize what it asks for. See? So clearly it is asking for two lists. Your X is going to be list 1 and your Y is going to be list 2. If you have a frequency list, you plug it in. And if you want to store the equation of the regression to graph it in y equals, you can put it here. But strictly speaking, you only need to put L1 and L2. Now notice, L1, let me just write it down so we don't forget. So L1 is going to be your X, and L2 is going to be your Y. All right, that is how they want you to plug it in. Yes, you can switch around, pressing second and one of the blue buttons down here, but we're just going to be consistent with what our calculator shows. X is going to be L1, Y is going to be L2, okay? And so once we've established that, you go back, so you gotta go stats and then edit in order to bring up the lists. And so L1 is gonna be your X values and L2 is gonna be your Y values. Following what I said earlier, number of children in this context is gonna be X. And so you're gonna go ahead and plug in 81, 175, 202, 346, and 360. And then we double check real quickly because we all make mistakes. Nobody's human. I mean, we're all human, sorry. Nobody's a machine is what I mean. Yeah, L2 is going to be 15, 27, 23, 35, 46. We double check real quick because why not? Everything's aligned, so notice how the 360 goes with the 46, right? The 35 goes with the 346. That is also important. See, you want to make sure it's all aligned. 23, 202, 175, 20. Yeah. All right, beautiful. And so now and only now you can go to stat, calc, and line reg. See? So if you go ahead and calculate from here, bada bim, bada boom, that is what you end up with. And so here, let me just write down like everything. So here it says that y equals ax plus b, right? And what it's telling you is that a equals 0.0935. And that b equals 7.43. All right, I did this using significant figures. Let's recall that for significant figures. For example, if you have here 1, 1, and here you have 0.53. Significant figures, you count them like you don't count the zeros. See? Or at least until you reach the first number, you don't count the zeros. So you don't count this, you don't count this, but you say 1, 2, 3. Do you round it up or keep it the same? You keep it the same. So for significant figures, it's 0.0935. And down here, you would count 1, 2, 3. Round it up or keep it the same. Keep it the same. 7.43. Right? So that is with significant figures. And what this is telling you, all right, is that if you plug in A and plug in B, you end up with y equals 0.0935x plus 7.43. Right, so this is much more similar to what we wanted as a regression equation. You just plug in A, plug in B into this right here, and there is your equation. See? Now, before I move on to part C, I'm sure there's at least one of you thinking, what if they're asking for the correlation coefficient? See? And this is not part of this problem, but it will point it out because it does show up a lot. See? Sometimes they ask for the correlation coefficient. All right, and the correlation coefficient is a little bit different than like this equation. Okay, the correlation coefficient is an R value. All right, and the R value should be showing up in your calculator, but I'm sure for some of you it doesn't. So to have it show up, you press mode. You make sure that you have this thing of stat diagnostics turned on. And now if you do line reg again, you're gonna see that they give you an R value. Okay, so if you ever need to get the R value, it's also with line reg. So that's also a procedure or a buzzword I need to keep in mind. The correlation coefficient is also going to be with line reg. And you need stat diagnostics on. Okay, so careful with that. You might as well keep it on. It gives you more information. See? Anyways, enough blah blah. That is for part B. And for part C, it's fairly simple. You just need to use this regression equation, right, to predict, what are we predicting? The number of ice creams, right? And so we're predicting the number of ice creams. Number of ice creams we said was y, so we're predicting out some y, knowing that use your regression line. Oh, this one's interesting. So here it says, use your regression equation to predict the number of ice creams, so the y of the regression equation, that the vendor sells on a day where the highest temperature is 25 degrees. Now, this is the thing, see? So for part C, it actually gets very juicy, see? So for part C, we have a couple things like happening, see? So basically, on the one hand, you have your regression equation, which is on the y, you have ice creams. So you have ice creams for y, and you have numbered children for x, right? And so here you need to predict the number of ice creams. So you need to find this guy, knowing that the temperature equals 25. Now, my regression equation in part C uses ice creams and uses number of children. It doesn't use temperature. So why would I use temperature here? Well, because technically you can take this temperature and plug it into part A. Why would I do that? Because part A, given your temperature, you get a number of children. So, basically, it's like a two-stepper. See, on the one hand, you gotta plug in the temperature, right, into the problem from part A, right? And through this, estimate the number of children. And once you have the number of children, you put the answer from part A over here, and you find the number of ice creams. See? So it's definitely a two-stepper, and you have to have really clear that you're not plugging in 25 children, you're plugging in 25. You're plugging the number of children you get when you have a temperature of 25. Now, thankfully, the equation from part A asked us specifically to find the amount of children when the temperature is 25, all right? But just so that so basically you're just plugging in 310 here, see? Because it's the answer from part A. It's what the number of children we found when the temperature was 25. But just so that we all understand and we really manage these concepts well, if part C was saying, predict the number of ice creams that the vendor sells when the highest temperature is, I don't know, 30. See? And so if it was 30, then that means that you have to go back, right, to your regression equation. Go back to part A and plug in 30 instead of 25. And then this 260 is what would go in your regression equation for number of children. See? And so be very careful with that. I feel like this exercise really tries to sort of confuse you with the concepts and this or that, understanding what is X and what is Y and all that stuff. But once you understand that, it's actually very, very easy. See, I think this video is kind of long just because I'm explaining concepts more than the math being actually like really hard. See? So anyways, that was a quick explanation. If the temperature was 30, you would just have to plug into the equation of part A a temperature of 30, find the number of children, and that number of children is what you plug into your regression equation. Now in this case, as I said, it's just your answer from part A, because part A is asking for a temperature of 25 as well as here, right? So you just plug in an x of 310. See? So in your regression equation over here, we will be having 0.03935 times 310 plus 7.43, right? And so what is my y value, right? What is my y value when I have an x of 310 or a number of children of 310? Let's put this into our graphing calculator. We end up with 0.0935 times 310 plus 7.43. Let me check that all my values seem correct. Yes, they do. And so for the for the ice creams sold, we can put 36.415. All right. It doesn't say like to the nearest number or anything like that. So the number of ice creams, I would just leave it as 36.415. I guess technically you can't say 36 or 37 because you can't really sell half an ice cream, but that does get debatable. Point is, if you reach this point in your answer, you already got far enough. See? So again, a lot of these is just concepts, understanding what is X and what is Y, and which is why I spent a lot of time talking about independent and dependent variables. See? So keep that in mind that independent is always going to be X, the dependent is always going to be Y, and your Y equals, right? Whatever is alone is the dependent. Keep that idea in mind. Whatever is alone is your dependent. All right? So ladies and gentlemen, I hope it helped. Remember that whenever they ask for a regression equation or for R value, you're thinking in line reg. See? So anyways, I hope it helped. I'll see you around and take it easy.